Hi, this is Cody. I'm going to have the first tutorial of this semester for thermodynamics. And this question we're gonna study the properties of a substance. In all these questions that I'm going to solve today, the substance is water, but no matter what substance we use, the procedure is always the same. So in this question we're gonna find the state and some missing parameters or properties of water. This question has three parts. First of all, in part A, we're going to find the pressure for water at the temperature of 40 degrees Celsius and specific volume, that's small v, 15.6 meter cubed per kilogram. Okay, in order to actually find the properties, find the missing properties, I need to use the table that belongs to saturated water. You know that, as you see in the picture here, we may have a compressed liquid, saturated liquid. We may have mixture, which is called saturated liquid vapor region, or mixture of liquid and vapor. At the right, at the right, which is corresponding to this line, we may have saturated vapor, and anything after this line, which corresponds to this region, is superheated vapor. In this question, I don't know what it is. That's why I have to start from saturated water table. If I just open the table that belongs to saturated water at the end of any thermodynamics book, you will see that the properties are listed according to temperature. That's called temperature table, or sometimes it's ordered like the pressure is the first parameter in the table, and it's listed according to the increasing pressure. We need to use the temperature table for this problem, since the temperature is given to me. I look at the temperature of 40 degrees. Actually, I didn't copy all the tables, so in the book you may have much bigger table. I just copied the part that we need to solve this problem. Since the temperature is given, I just highlight this line and I focus here. This table tells me that at the temperature of 40 Celsius, the saturation pressure is 7.38. So the pressure corresponds to this line that I'm highlighting here. For example, this pressure, this line is referring to the pressure of 7.3851 kilopascal, and this is the saturation pressure. At this pressure, when water is at this pressure and this temperature, it may have two, it may be saturated liquid, it may be saturated vapor, or it may be something in between these two, which we call it mixture. So the first number here shows the saturated liquid VF, specific volume of saturated liquid, and the second number, 19.515, shows the saturated vapor specific volume. In other words, this point here, where temperature is 40 Celsius, specific volume is 0.001,008, and the other point at the end of the straight line at the right, we will have saturated vapor with a specific volume Vg. The other one is Vf. You can highlight this way. Vg, that is equal to 19.515 meter cubed per kilogram. So all the numbers here, specific volumes, are meter cubed per kilogram. Anyway, after studying the table, I need to compare the number that I have with what table tells me. According to the table, 19.515 refers to the specific volume of saturated vapor, and the specific volume that I have in this question, 15.6 meter cubed per kilogram, is smaller than that. In other words, I can write this way: V is smaller than Vg, specific volume of vapor, saturated vapor, and specific greater than specific volume of liquid. This case is a mixture. So this is a mixture. V is between Vf and Vg. Temperature is 40. P is the pressure of saturation, which I wrote it earlier, 7.3851 kilopascal. And if I need to find the state, the quality, sorry, if I wanna find everything that I need, one of them is missing, is the quality. That's why still I need to work and show the corresponding point on the curve. Let's say this point corresponds to the situation that we have here, specific volume of 15.6. So I can highlight here that this specific volume V is 15.6, and in order to find the quality, I can use this equation: X equals V minus Vf divided by Vg minus Vf, which means I need to subtract 15.6 minus 0.001008 divided by 19.515 negative 0.001008. Remember that the x doesn't have any unit, so 15.6 minus 0.001008 divided by 19.515 minus 1008. I get x equals 0.7993, or I can write it as 79.93%.